Hey guys, this is Miss Smith. We're going to be doing Unit 9.4, Area of Composite Figures. Okay, so first off, a composite figure is made up of small geometric shapes like squares, rectangles, etc. So what we're doing is we're combining area together. So we might have a shape that consists of a triangle or a square put together. Okay, so we're going to be doing area of individual shapes and then putting them all together, which is called a composite figure. Okay, so our steps, in order to find the area of a composite figure or any other irregular shaped figure, you need to, first step is identify shapes within the composite figure. So we might have, like I just said, a shape with, let's say, half a circle and a triangle. Okay, so what we would do is we would identify the shapes first and then divide these then divide these simple non-overlapping shape figures. Okay, so we need to draw each shape separately and know and identify what shapes we're working with from our formula chart. Okay, then we find the area of each shape. Easy, right? Because we should know the area for all these shapes right here. I put together kind of a little formula chart here. It's not exactly like your formula chart from what I gave you, the yellow sheet, or what Miss H gave you, but it's very similar. Okay, so then we add all the areas of each shape together to solve for the area of the entire composite figure. Okay, I hope I went slow enough for you to write each blank. If I went too fast, then you can pause me. Okay, so example number 1. Okay, this is called a composite figure. It's irregular shaped. Okay, so what shapes do you see in this figure? Give you a second. What shapes do you see? Good. Okay, I see one triangle, then I see another triangle. Okay, and then I see a rectangle. Okay, so if we split these, this is what we're going to have to do on your assignment, is you're going to have to redraw them. Okay, triangle number 1, triangle number 2, and then our rectangle, to figure out the area of each of these. Okay, so first, let's do the triangle of the, one of the triangles. So, it's not written here, but what's the other dimension? Okay, it's a 2 by 3 feet. Okay, so our formula for, and I didn't get this on here, you look on your formula chart. So the formula for a triangle is half of base times height. Okay, so we're going to rewrite it, base times height divided by 2. So I think Miss H probably showed y'all this. Okay, so we're going to have our base times height divided by 2. How do we know what our base and height is? Exactly. It's connected by the right angle. That's how we know. Okay, so we're going to do 2 times 3 divided by 2. 2 times 3 is 6. Divided by 2 would be 3 feet. Okay, so our area for triangle number 1 is 3 feet. All right, so we got step number 1 done. Now let's do another shape, which I see another triangle on here, which I'm going to rewrite my formula, base times height divided by 2. So here we have our base and height is connected by the right angle. So we have 3 times 3 divided by 2, which would be 9 divided by 2, which is going to give me a decimal, 4.5 feet. Oh, I forgot to put squared. Gotta remember to do that. Okay, on the rectangle. Rectangle on your formula chart actually, I believe, is with the parallelogram which says base times height. But we have to know that length times width is the same thing as base times height. Alrighty, so we have a lot of extra numbers here from when I copied and pasted it to over here, but we got to focus on just our base and height of our rectangle. So I'm going to give you a second. What's the base and the height? Good. 8. Oh goodness, that was not a very good 8. 8 times 4, which would give me 32 feet squared. All right, very good, you guys. Now, how easy was that? Y'all know how to do each of these 3 shapes separately. And now all we got to do to find the area of the entire thing is add 3 plus 4.5 plus 32. Now this also can be a decimal lesson. Make sure you line up your decimals since we have a decimal involved. So I'm going to give you a second, add these up. 3 plus 4.5 plus 32. Okay, bring my decimal down. 479. So my total area is 39.5, or 39 and 5/10, 39 and a half, same thing. All right, guys, this should be pretty easy because we know how to do the area of each shape. So we just got to make sure, we find what kind of shapes are in it. Okay, here's another example. So what shapes, I want you to just think to yourself, what shapes do you see? Okay, I hope you said a rectangle. And clearly I know it's over here, but rectangle. And then what do you think this shape is? It is, very good, half of a circle. Okay, and we call this a semicircle. So when we have semicircles, okay, we got to make sure we do our circle formula. So let's start with the semicircle first. First things first, I'm going to get my diameter. Now, I don't see anything right here. So what is my diameter? Okay, and then we need the diameter to find the radius. So what is my diameter, do you think? Okay, good. It is 10 because this side is 10, same length as here. Okay, so our diameter is 10 meters. So what would that mean the radius is? Very good, 5 meters because we need radius for area. All right, so I hope you rewrote your area formula to 3 times r times r. Okay, so let's substitute it in. So it'd be 3 times, my radius was 5, times 5. Okay, so 3 times 5 times 5 would be 25 times 3, which would be, well, we can do that in our head, which would be 75. Okay, now, do you think this is going to be my area of a semicircle or a half circle? No, what do you think I need to do? Good, you're going to divide by 2 because it's a half circle. So circles can be, half of a circle or 1/4 of a circle. So whatever, it's split into is what you're going to have to divide by. So 75 divided by 2 is going to give me 37 and a half. Okay, circles can kind of be tricky here. So meters squared. So that's my area for the semicircle. All right, square, really easy. Okay, you can do s to the second power, which means s times s, just for a square since the sides are the same. Or another way you could do it is base times height. Okay, it's going to be under your rectangle or parallelogram. And we talked about that in class. So easy. 10 times 10 is 100 meters squared. All right, we got our 2 areas. So now what do we need to do? I knew you would know. Good job. We're going to add all our areas together to get the total area of the entire thing. So it's going to be 137 and a half, or 137.5. So our total area is 137.5. Okay, should seem pretty easy, you guys, but one thing I need to show you for tomorrow is sometimes you're going to see something that looks like this. It's not going to have this involved. What would this be? Good, 1/4 of a circle. So instead of dividing by 2 like we did this for the semicircle, we're going to have to divide it into 4s if we have 1/4 of a circle. So that's just something that you might see later that you need to know knowledge of. All right, guys, we're almost done. Example number 3. All right, a uniquely shaped banquet room is being carpeted. Oh my goodness, can't say that word. Okay, a floor plan of the room is below. Here's our floor plan. Each unit represents 1 centimeter. The carpet costs $23. I think I changed that on y'all's notes. Actually, we're going to change this to 12. It'll be a little easier. So the carpet costs $12 per square centimeter. How much will it cost to carpet the room? So this kind of question, if you see it, we have a picture here. So we're going to have to know what the area is of the entire thing. When we first look at these kinds of shapes, we're like, oh my goodness, how are we going to find that? Well, we're going to have to pick out our shapes that we see and do them separately and then get our total area just like we did on the others. But of course, they're going to make, the question a little bit more complicated. So in this one, what do you think we do in the end? Okay, I'm going to let you think about that for a second and then we'll get there after we get done. Okay, so first thing, I have a parallelogram. And I see that right here. Now, look at the difference between a parallelogram and a trapezoid. Guys, I get them mixed up too. You've got to realize that if you have 2 pairs of parallel lines, it's going to have to be a parallelogram. And of course, the name is parallelogram. So parallel, okay? Trapezoid only has one pair, all right? So these two are going to be not parallel. These two are my parallel lines, right? Okay, oops. And then over here I have, here's a pair, and then here's a pair. So you have to, you know, kind of think about parallelograms and trapezoids because they can be really tricky. And guys, I do the same thing. Get them mixed up. All right, so parallelogram on our formula chart is what? Good. It's with triangle, so base times height. What's the one thing we look at for base times height? One thing we look at. Good. Right triangle. Okay, so we're going to plug in our base and we're going to plug in our height. Now, a parallelogram is a slanted rectangle. So I know that opposite sides are going to be equal. So if this is 10, it does not tell me over here, does it? But if I know this is 10, then what does this have to be? Good, it has to be 10. So, easy. Base is 10 times my height, which is connected by the right angle. So 10 times 1.5 is going to be 15 centimeters squared. Okay, awesome. Parallelogram out of the way. Okay, now let's do trapezoid. A little bit more complicated formula, but it's actually really easy. Let's go ahead and put, since we knew that this was 10, let's go ahead and put our side here because you might have to figure it out. All right, so now let's write our formula. Base 1 plus base 2, which is my one pair of parallel lines, times the height, all divided by 2. Remember how easy this formula is, even though it looks hard? All it is, add your bases, multiply by the height, and then divide by 2. Like, really easy. It looks complicated, but it's actually a really easy formula. All right, so what are my two bases? Two parallel lines. Good. 10 plus 7. What's my height, and how do you know? Good, I knew you would say that. Connected by your right angle. Okay, so then we're going to multiply by 1.5, and then divide it all by 2. All right, so I'm going to give you a second. Pause me. I want you to work it out, and then let's see if we get the same thing. Okay, so should have got 17 times 1.5. Oops. And divide by 2. Okay, so I got 12.75 centimeters squared. Hope you got the same thing. Alrighty. So to find the total area, I'm going to have to add 15 plus 12.75. Make sure you line up those decimals. Okay, we should end up with 27.75 centimeters squared. Okay, so my total area is 27.75. This should be centimeters squared. Okay, now what does the question say though? You'll always have to look for that extra step because it's going to be probably an easy extra step, but they're always going to trick you with something. So we got to be prepared for those kinds of things. So at the beginning I asked you, what do you think we do? Okay, let's restate the problem. The carpet costs $12 per square centimeter. How much will it cost to carpet the room? What do you think we do? Good. Multiply. Okay. 27.75 times 12. Okay, pause me, work it out, let's see if we get the same thing. Go ahead and change the color while y'all are working it out so y'all can see it a little bit better. Okay, we should have gotten 333 centimeters squared for how much it would cost for the room. So you know this answer right here is going to be an answer choice because they're going to think, you know, they stopped at the entire area, but you got to be careful. Okay, you got to go one more and the answer is going to be 330 centimeters squared. All right, guys, gotta always use your formula chart and make sure you do each shape separately and then, you know, figure out what the question's asking. All right, guys, y'all are awesome. Make sure you scroll down and answer the questions and press submit. We'll be checking. All right, y'all have a wonderful night.